Hi everyone, this is Igor from hdhead.com. In this Avid DS tutorial, we're going to learn how to make a waving flag. And this tutorial goes out to DS artist Sean Stahl, who convinced me using very colorful language in a thread at DS Google list that the particular tool that we need for this job is actually still in DS version 10, which for some reason I thought was removed. But he was right, I was wrong. But let's look at the waving flag. Here's an example of what you can do in the DS creating a waving flag. This kind of a look was popular for a while for lower thirds in sporting events. Now, I don't really watch too much sports other than World Cup skiing, and they haven't been using this for a while, so I'm not sure if this is still hot or not. It is a little dated, but let's look at what forces are at play. A blowing flag is affixed at least two corners like this, so those are fixed points that don't move. And across the flag, one of the forces is wind that makes the flag flap, and it's fairly random. And of course, the flag will always position itself so it's moving downstream from the wind. This particular force is possible to simulate in DS. The other force is the force of gravity, which pulls the flag down, and that's something that we can't really simulate in DS. So the type of flag we can create is not terribly realistic, but it could be useful for some applications, as I mentioned, lower thirds, things of that nature. The tools that we need for this exercise are Fractal Noise Generator and 3D DVE. At this point, if you're not familiar with Fractal Noise Generator, it would be worthwhile to check out a tutorial I did a little while ago called Fog and Smoke, where we use Fractal Noise Generator to create fog and smoke effects in DS. And another useful tutorial would be the one on creating composite containers. Everything we do in here we'll do within a tree context, so you need to know how to work in this particular mode of DS, although what we're set to achieve is very simple. So let's look at each one of our pieces in here. To do that, we'll select a node and click letter V on the keyboard. This is just a flag, and it could be any picture, it could be moving video. This here is a rendered cache of the fractal noise, which creates the motion of the flag. And this node here combines these two things into a waving flag. 3D DVE does most of the heavy lifting, so we'll look at that first. We'll take it from up there, bring it down here, connect the output of the node to the output of the tree. And so far everything's good. We're seeing black because nothing is going into the 3D DVE. We'll take our flag and feed it into input 1. So here this flag is coming through unaltered. We'll double click 3D DVE to enter the effect, and we're going to set up a couple of things in here. First of all, this is a three-dimensional environment. We can rotate our virtual camera, and we can set the surface properties, which is important for a waving flag, because without highlights and shading you wouldn't really see much of the folds. And to do that, we'll select the object, which is now movable, and click on the first button, which will bring up the surface properties for this particular input. We will enable lighting to see that we're actually able to light this thing up. I will click here on this lamp icon, which allows me to see light. I can move this light and you can see it's lighting up the object in real time. At this point, I'm going to lift this light up, right click and add a light. So we have two lights. We're going to change the intensities of these two lights. I'll set the top one at 40%, and I will also make this one slightly blue, and I'm going to set the bottom one at 30%. Maybe we'll alter those values later, we'll see. Select the object and click on the second button down that has an icon of a page peel that says DV Property Editor. So this is where we can change the displacement mapping for this object. And displacement mapping is a technique where the geometry of an object is altered by a grayscale image fed into, in this case, 3D DVE. In order to do this, we actually need to feed a black and white matte that will do the warping of the image. There are some built-in displacement effects like page curl, ripple, and sphere. Ripple can be used to some extent to create a very stylized looking flag. We will create concentric ripples emanating from the center, but we will leave this in the default position so we can feed another image in there. So I'm going to close up all these windows and go back to our tree, and we're going to take another graphics effect down here, connect this black generator into the graphics. Double click that, set up a brush, turn off the fill. Let's create a large brush, and the color is white, so we'll paint with white over black. We'll exit out, select the 3D DVE. We can right click and say add remove inputs, add input. And shortcut for this is letter A on the keyboard. We'll feed the output of the graphics into the newly created inputs 2 in 3D DVE, and then we'll double click the 3D DVE. So now you see what's going on is there are two objects sandwiched in here. We can actually select our stroke and delete it. It's not consequential for what we're going to do. Now we'll select the remaining flag, click on the DVE properties, and as displacement texture, select input 2. And as you can see, the shape that we created is now creating embossment in our flag. It's very rough because the filtering is set to very low detail, but if we change the detail values to 10 and 10, you'll get a fairly smooth looking shape. So that's the idea. If the black and white matte we're feeding into 3D DV is animated, as it is with the case with the flag, that will cause the flag to move. Now let's quickly look at these other values that we can adjust. I'm going to select the flag, and we'll knock down the detail to 5 and 5, which will allow me to move a little faster here. The scale amplifies the extrusion effect. Remember, white will produce fully extruded shapes, black will not affect the geometry at all, and everything in between will stretch between the maximum extrusion and no extrusion at all. But we can multiply that with the scale factor. So a scale of 100 will create that. And let's put it back to a more reasonable amount, maybe 12. Offset actually moves the 0 value base. Like, see, offset was, I believe, at 50 by default. And you can see the difference in position between the flag and the bounding wireframe. If I put offset back to 0, it will snap in. And lastly, softness. We can make this thing very sharp, or we can add a whole bunch of softness which will smooth out the relief. So now see the walls of the extrusion are not as sharp as they used to be. For example, if you were to bring in topographical elevation data, you could use softness to improve the model by softening over adjacent samples. Then we have the surface properties for the object, and as we saw earlier, enable lighting allows us to see shading. This is what the same thing looks like with lighting disabled. It's very difficult to see what's going on. Although the geometry is there, you can, if you see the profile view, you can see that the thing is raised. But until you enable the shading, you really can't see it. This is the color of specular highlight. Let's see if I make the specular highlight red, what that does. This is the emissive color of the object itself, sort of a object glowing from within. You probably want to have that at a fairly low level. And shininess affects the sheen of the object. This is a low value of 1, high value of 100 for more metallic looking objects. Maybe that's a little too high for this one. 40. That's a little better. You can see how that affects the specular highlight. We're going to look at fractal noise now. I'll click on fractal noise, bring it down here. We'll connect the output of the fractal noise to our output node. We're going to tweak a couple of parameters to make it more flag-like. We'll double click the fractal noise, and this is getting messy down here, so just so you have an idea what I'm doing, I'll put the fractal noise node up there. So these two things are the only thing we're concerned with right now. The number of octaves is, see, with a high number of octaves, this already starts looking like smoke, which is not going to help us with the flag. So we need a lower number, but for the complexity of the wave surface and the randomness, it's good to use more than 1 octave, and 2.1 works particularly well, I think. The base animation velocity is what makes the fractal noise move. So a high number will make it move fast, low number will make it move slower, and I will try 0.5. We'll leave the octave mixing weight, octave scaling ratio, and the velocity ratio at the default settings. We'll move to the transform tab. This one is important for the flag. If you want to make it appear as if the wave is moving from the left to right, we're going to keyframe the X position at 0, and then we'll move some number of frames and increase this value to, let's try 12. I mean, this is largely trial and error until you find a speed that works well. We'll keyframe that. We'll right click onto the key and convert this to linear, and we're just going to scrub the timeline and see if this works well. I think I need to increase the number quite a bit, so let's try 120, 10 times more. Keyframe that, and now you can see there's a sense of the texture moving from left to right. If I push play, you can see it moving to the right. Another thing we're going to do is we'll change the vertical scale to 150 or 200, something like that, so we have vertical waves. And everything else we can leave in default. The color really needs to be black and white. We can play with the density and offset later, but for now this is good. So what I'm going to do is I will lock the properties of Fractal Noise and put this back here and connect it in place of the graphics node into the inputs too. And we'll take the output of the 3D DV to the outputs. Go back to 3D DV, select the object, which by the way now is distorted. You can see the little bumps and valleys in the flag. I will move the detail back to 1 and 1, and if you put a higher softness that smooths over all these bumps, we'll go back to the tree. At this point I'm going to play with the fractal noise to see how changes here affect our flag. So for example, if we reduce the number of octaves, we get a less complex wave surface. This is getting more turbulent with higher frequency waves. So we'll put that back to 2.1. Then we'll play with the octave mixing weight and octave scaling ratio to smoother surface. Pull this number down. Go to transform. Let's try to, instead of 150, go 300 on vertical scale. So this gives us what we expect of a flag, or at least of a stylized cartoony flag, to have nearly parallel wave fronts across the surface of the flag. Let's render this and see what it looks like when it plays back in real time. We'll loop that. So it's kind of a very slow motion flag, and that can be easily adjusted using the base animation velocity. Let's try just to see how that works. Let's go, instead of 0.5, let's go to 4, make it really fast. And also, if you advance to the second keyframe of this X translation, instead of 120, let's say 500 for this keyframe. Render that. So that's kind of getting there. In the end, if you feel like I was a lousy instructor and you didn't learn much, or if simply you don't have time to mess with these fractal noise parameters with a client sitting behind you, you can just go to hdhead.com and download the waving flag preset.